Hello everyone, today we're going to talk about how to solve word problems using proportions. So these are the steps we're going to follow for every single problem that we have. This is going to help break it down a little bit, make sure that we have a process to follow, and make sure we're not making any mistakes along the way. So after we read the problem, step number 1 is going to be to underline or highlight your number with your labels. So in these proportion problems, we always have two different kinds of labels. So we have something like inches and centimeters, or time and money. So there's always going to be two separate things we're looking at, and we want to make sure we're keeping it organized right from the beginning. Number 2, if there's not a picture, a lot of times it's helpful to draw one just so we have a visual that goes along with our problem. Number 3, we are going to actually start setting up our proportions. Remember, the proportions is that fraction equal to another fraction, and we're going to first focus on that first fraction by finding the two things that are equal to each other. So this many inches is this many centimeters. This much time gives us this much money. Once we have that with our labels, we write them into that first fraction. Now, the labels are important because they help us know for number 4 where that third number goes. So there's always going to be a third number, and we use the labels to figure out if it goes on the top or the bottom. And from there, we just solve with cross multiplication or the butterfly method. Now, before we get into some examples, there is a specific kind of word problem that we'll see a lot called a scale drawing. Now, a scale drawing is where we have something that's either too big or too small in real life for it to be practical for us to look at. And so what we do is we scale something up or we scale something down so that we can actually look at it and we can use it in real life. An example of this would be like the Maps app on your phone, right? We can't take the whole country or the whole world and put it on your little phone, right? It's too big. So what they do is they take everything and they shrink it down, but they do it proportionally so everything still looks the same and everything makes sense. Another really common example are house or building blueprints, right? When you have the blueprints for something, they're taking that big building that's going to be built and they shrink it down to a small piece of paper so that the people who are building it or working on it or designing it can use that in a more practical way. And another example of something that's maybe too small to see in real life, think about science, right? When they show you those diagrams of like a cell or anything that's like you would be looking at under a microscope, they're taking that really teeny tiny thing and they are making it bigger so it's more practical for us to see. In all of these cases, we have something that's called a scale, and that tells us how they either made it bigger or smaller. So when you have a scale, the model size is always going to come first or be on top, and the actual size is always going to be on the bottom or come second. Let's take a look at an example of a scale drawing right over here. So we have a scale drawing of a house, uses 1 inch, that's the model, for every 5 feet in real life. The house is 20 feet tall, so how tall would the house be in the drawing? So you can see that they already have the highlights with the labels and the numbers together, and we're going to look at that first fraction is always going to be those two things that are equal, right? 1 inch equals 5 feet, so that is where that first number comes from. Now, using those labels, I can take that third number of 20 feet, and I know it has to go on the bottom with the other 5 feet. And now my how tall, that's my missing value, that's going to be the variable, and it goes along with those inches on the top. From there, you would just cross multiply and solve, and we would be able to answer the question. All right, so let's go ahead and take a look at some problems that you might see on a quiz or a test there at the end of the year. Okay, so we have a school building casts a 98-foot shadow. At the same time, a 22-foot flagpole casts a 77-foot shadow. How tall is the building? So the first thing, again, we're always going to do is highlight those key words and numbers. So I know that we've got a 98-foot shadow, and I also saw that there was a 77-foot shadow. So this time we've got those heights are one of our labels, and our shadows are our other one. Now, we have a 22-foot flagpole. That means it's 22 feet tall. And we don't know how tall the building is, so that how tall kind of goes together. All right, here's an example where a picture really helps. They love to get these kind of shadow problems on tests and things like that. So I always have my students draw 2 big L's. And they don't have to be perfect, and they don't have to actually match up with the numbers, but we just want an L, so we've got the height going up and down and the shadows going across. I also like to label them so we know which is which, right? So we've got a school in this case and a flagpole. All right, let's fill in our picture with what we know. We said the school building casts a 98-foot shadow, so that 98 is going to go across the bottom. And we have a 22-foot flagpole, that means it's 22 feet tall, casts a 77-foot shadow. Now, we don't know how tall the school building is, so that's where my variable is going to go. So now I have this picture that matches up with my problem, kind of helps us give that visual. And you can see that that highlighting can come in handy with our picture as well, right? We had the 22-foot tall flagpole and how tall, right? So you can see that that X and 22 are corresponding and go together. We also had a 98-foot shadow and a 77-foot shadow. So again, you can see that those two things are corresponding. Now let's go ahead and write our proportion. So again, that first proportion is always the two things that go together, the two things that are equal. In this case, we know that a 22-foot height equaled a 77-foot shadow. So I'm going to label those right there. 22-foot height, I'm going to put H for height, is a 77-foot shadow over there. Now I've got to look at my third number. So that third number I have not used yet is 98. I know that that 98 is my shadow. So it's got to go on the bottom with my other shadow over here. And that missing value, that X, is the height that we're not sure about. So that's going to go on top. All right, now go ahead, pause the video here, solve that proportion for that missing side. All right, how'd we do? When we cross, multiply, and divide, we should get 28 feet, which means how tall is that school building? It is 28 feet tall. Again, we want to make sure our answer makes sense. We can see with that flagpole, that height was way smaller than our shadow was, right? 28 feet is smaller than that 98-foot shadow, so we know that everything makes sense proportionally. All right, we've got another shadow problem, so let's take a look. A 7.5-foot tall beach umbrella casts a 3-foot shadow. How tall is the lifeguard stand that casts a 2.4-foot shadow? Go ahead, pause, highlight, and draw your picture and see if you can get your problem set up. Okay, so we can see our umbrella is 7.5 feet tall, has a 3-foot shadow. Our lifeguard stand, we don't know how tall it is, casts that 2.4-foot shadow. So we're going to set up that proportion again. I know this time that we've got that 7.5 as our height and that 3 for my shadow. I've got that leftover number 2.4 is my shadow again, so that's going to go on the bottom. And that X is going to go on top. Go ahead and pause and solve your proportion. And we should get 6, so that lifeguard tower is 6 feet tall. All right, one more of these before we get into some scale drawing problems. So we have that kind of this triangle within a triangle that we've seen before, but now it's going to be in a word problem. So use the diagram below to find the height of the lamppost. Anytime we have these kind of triangles inside each other, we always want to redraw it out as two separate triangles. So we're going to have our big triangle for that light post and our small triangle for our person. I can see in this small triangle, I've got my 6 as my height and 8 as my shadow. And if we're looking carefully at this big triangle all the way across the bottom, I'm going to have to add those two together. So 12 plus 8 is going to give me 20 across the bottom, and I don't know how tall that is. So now let's go ahead and set up a proportion and solve. Go ahead and pause the video here so you can check your work. All right, and checking your work, we should have gotten that that lamppost is 15 feet tall. Let's take a look at some scale drawing problems. So, starting with number 4. Amelia made a scale drawing of her bedroom. The scale is 1 centimeter to 4 feet. If the length of her room of the drawing is 3.5 centimeters, what is the actual length of her bedroom? So, first things first, we're always going to highlight those numbers and labels. So I've got 1 centimeter and 3.5 centimeters. I've got 4 feet. And what is the actual length, right? That's going to be in feet as we get going. Okay, so we're going to set up that proportion. And again, my first fraction is always going to be those two things that go together, and a scale drawing is always going to be the scale. So my scale is 1 centimeter to 4 feet. So I've got 1 centimeter and 4 feet. Now, I know that when I'm setting these up, those labels have to stay the same across. So I know I'm going to have centimeters on top and feet on the bottom. My third number in the problem is that 3.5 centimeters. So I know that has to go on top based on those labels. That's why those labels are so important. I don't know how tall or how long the actual bedroom is, So that's going to be my x. So now that I've got my proportion set up, go ahead and pause, solve the proportion to solve for that missing length. So when we solve that proportion, we should get 14. And our label, we can always look at what the question is asking, right? What is the actual length? But we can also look in our proportion, right? Our x is labeled as feet, so I know that actual length of our bedroom is 14 feet. All right, number 5, Mario is building a model race car. 1 inch on the model represents 6.5 feet on the car. The actual length of the car is 16.25 feet. How long is the model? Okay, so I've highlighted our labels and our numbers. I want you to pause the video here and I want you to try to set up that proportion and solve for that missing length. And our answer for this one should be 2.5 inches. So we have x inches, 2.5 inches. That is how long the model is. All right, last problem for this video. We have the map below shows a trail around Mount Trashmore Park. The map scale is 1 centimeter, is representative of 0.5 miles. If you walk around the entire lake, how far did you go? So let's look at those labels again. We've got 1 centimeter on here, but notice we don't have another set of centimeters quite yet in the problem. So we're gonna come back to that in a second. But what we do know is 0.5 miles, and we want to know how far did we go, right? So how many miles did we actually walk? So we're missing that other number, that other set of centimeters. So what we need to do in this case is we're walking all the way around the lake. So we're gonna add up all those distances. 1.2 plus 0.8 plus 1.0. And when we add those all together, we're gonna get 3.0 centimeters. And so that is going to be that missing third number for our problem. So we're gonna set up that proportion. Again, I know that 1 centimeter is the same as my 0.5 miles. I've got 1 centimeter, 0.5 miles. So I know that those miles have to stay on bottom. Those centimeters have to go on top. I know that that third number, 3.0, is going to go on top, and that means our x is on bottom. So pause one last time and solve for that missing distance. And hopefully we got this. When we walk all the way around that lake, we are going to be walking 1.5 miles. All right, so I hope you have some good strategies to break down those word problems using proportions. I hope you have a great day, and I will see you next time.